In 2009, a group of crack student environmentalists were sent to a high-security detention center for a crime they didn't commit. They then promptly escaped from a max-security waste dump to the Wake County Underground. Today, still wanted by the school system, they work as soldiers of energy. If you have a problem, if no one else can help, and if you can find them, maybe you can hire the Apes team.
Zach, red plus blue equals purple. This changes everything. I know. No. Four.
Hi. You're probably wondering, what is nuclear fusion? Well, that's what I'm here to tell you. Nuclear fusion is where you take an atom of tritium and an atom of deuterium and you fuse them together. And in this fusing process, they create heat, and that heat is then turned into electricity. But the problem is with tritium, there are only 2.5 kilograms of tritium found on planet Earth. So we have to find another solution. This solution is lithium. What we do with lithium is we shoot a neutron at it, and that forces it to become tritium and helium. Then we take that tritium and fuse it together with deuterium, and it starts the nuclear fusion cycle all over again. The good thing about lithium and deuterium is they're very abundantly found on Earth. Lithium is found in rocks, and then deuterium is found in ocean water. So about 2 liters of deuterium and 250 grams of lithium could provide an average family for about 1 year.
Well, I suppose if you were to create a power plant that did nuclear fusion, all it would have to do is harness the excess heat that came from the reaction and heat up water, which would create steam, turning a turbine and creating electricity.
There are 3 different kinds of nuclear fusion. They are called locally cold fusion, generally cold locally hot fusion, and hot fusion. The first, which was cold fusion, would be a great kind if we could use in a nuclear fusion reactor. However, it's not going to be able to because the muons, M-U-O-N-S, which are fused together in the process, only have a half-life of about 2.2 nanoseconds. And the chances that those particles will bind to other particles and stop the reaction are very high. The second kind, which was generally called locally hot fusion, has a couple different kinds of reactions in it. They are accelerator-based light ion fusion, which is where you have a particle accelerator and you smash these 2 different particles together and they fuse, and then you take the heat from there for the energy. There's also sonoluminescence, which is the idea that when bubbles in a liquid pop, the gases within the bubble fuse. There's also antimatter initialized fusion, which is where you have a small amount of antimatter to trigger a tiny explosion, which would fuse the particles together. However, this isn't feasible at all, because even if we can create antimatter, the cost to do so would be extremely high. And lastly, for hot fusion, which is the most common kind of fusion. Hot fusion is actually what occurs on the surface of the sun, and that is where we know about it from. The only bad thing about that is that the temperatures required to create hot fusion are insanely high, and the pressure needed to create nuclear fusion is insanely high. So this would be the kind that we would actually use in a nuclear fusion reactor, just the only thing is the energy required to create the energy might not actually create more energy in the long run.
Nuclear fusion, and I've seen many of the pros outweigh the few cons. The pros include the chances of a catastrophic accident as compared to fission reactions are much, much less. In a fission reaction, after the accident happens, it can continue for hours, perhaps even days. In a fusion reaction, if an accident were to occur, the reaction would probably end almost immediately because the parameters needed for a fusion reaction to take place are so specific that if they were to be messed up, it would just stop. The byproducts of nuclear fusion include tritium and helium. Helium, which is the main byproduct, is very, very safe and causes pretty much no damage to the environment. The amount of available fuel we have for nuclear fusion is estimated to last us 10 times the approximate age of the universe today. That is a big number, Bartholomew. One of the few cons of nuclear fusion is the byproduct tritium, which is an isotope of hydrogen. Though this is easily alleviated as a con, given the fact that tritium only has a half-life of 12 years, which is much less than any of the byproducts produced in nuclear fission. Another quite drastic con of nuclear fusion is the intense amounts of energy just required to pull off this chemical reaction. The amount of energy required for nuclear fusion is so gargantuous that it has not even yet been achieved on Earth. It's okay, Bartholomew. We'll get there. We have the technology.
Wait, are you recording?
No, not at all.
It's a good part that one.
This is an important aspect of fusion energy in contrast to many other energy sources that the con of... No, that's not it.
Since tritium is very rare and not found in a plethora of... I don't know how to word that.
Okay.
Pros of nuclear fusion.
There's cold fusion. Locally cold... Generally cold, locally hot fusion.
So Gary, after you win the Super Bowl, what are you gonna do?
After I win the Super Bowl?
Yeah.
Hey, it's a good question.
Oh my.
First thing I'm gonna do is kill him.
No, that's not in the script. What? I'm going to Disney World. Get this right. No, take two. Take two. There. Take two.
I'm going to Disney World?
Yeah. Get out of my way.